Have you ever wondered what existed before the universe? What sparked the Big Bang? Let's take a journey back in time, over 13 billion years ago, to the very moment that started it all. Imagine a cosmic explosion of unimaginable magnitude, a point in time and space where everything we know and everything we don't know began. This event, famously known as the Big Bang, is believed to have given birth to our universe. In the moments following the Big Bang, the universe was an incredibly hot, dense soup of fundamental particles. Picture a realm so scorching, so intense that atoms couldn't even form. Instead, what filled the universe were the most basic building blocks of matter, particles like quarks and photons. It was a time unlike any other. A time when the universe was too hot and too dense for anything but the most fundamental particles to exist. But as quickly as it had exploded into being, the universe began to expand. Picture an inflating balloon or the frothy explosion when you pop open a bottle of beer. As the universe expanded, the immense energy of the Big Bang was spread out, or diluted, across a larger and larger volume of space. This rapid expansion had a profound effect. It made the universe cool down. Just like the beer in the bottle, the universe began to chill as it expanded. This cooling was a game changer. It set the stage for the formation of matter as we know it. With temperatures dropping, the universe was no longer too hot for particles to come together. It was ready for a transformation, ready for the birth of matter. In the blink of an eye, the universe expanded, cooled, and set the stage for the birth of matter. This was the first act in the grand cosmic drama that eventually led to the formation of stars, galaxies, and planets. But that's a story for the next scene. For now, let's marvel at the wonder that is our universe, born from a cosmic explosion and a rapid cooling, a universe that is still expanding and evolving, just like our understanding of it. So, how did the universe transition from a hot, dense point to the birth of matter? Let's take a journey back, way back, to a brief moment after the Big Bang. Imagine an enormous cosmic explosion, creating conditions unlike any we see today. This universe was incredibly hot, too hot for anything other than the most fundamental particles like quarks and photons. As the universe expanded rapidly, the energy of the Big Bang started to spread out or dilute in space. This process resulted in the universe cooling down, much like how opening a beer bottle causes the gas to spread into the air and the beer to chill. This rapid cooling was the first step towards the formation of matter as we know it. About 1/10,000th of a second after the Big Bang, protons and neutrons began to form. These are the particles that make up the nucleus of an atom. They are the heart and soul of every atom, the building blocks of matter. Within a few minutes, these particles started sticking together to form atomic nuclei, mostly hydrogen and helium. Fast forward hundreds of thousands of years, and the scene takes a significant turn. Electrons join the party. They start sticking to the nuclei to make complete atoms. These atoms are the building blocks of everything we see around us today. Now you might wonder, what happened next? Well, about 1 billion years after the Big Bang, gravity started doing its thing. It caused these atoms to gather in massive clouds of gas, setting the stage for the formation of galaxies, which we'll delve into in our next scene. Gravity, that mysterious force that pulls objects with mass towards one another, played a crucial part in the birth of matter. It's the same force that causes a ball thrown in the air to fall back to Earth. And so, the universe went from being a hot, dense point to a cool expanse filled with the building blocks of matter. And thus, the seeds of what we now know as matter were sown into the fabric of the universe. But how did these atoms cluster together to form the vast galaxies we see in our night sky? Picture the universe as it was about 1 billion years after the Big Bang. It's a cosmic soup, filled with atoms, mostly hydrogen and helium, scattered across the vast expanse of space. Now let's introduce the real star of this cosmic drama, gravity. Gravity is a fundamental force that pulls objects with mass towards each other. It's the same force that keeps us grounded on Earth, and it's the same force that began to pull these atoms together. As gravity worked its magic, atoms started to cluster, forming massive clouds of gas. These weren't just any clouds, mind you, these were the nurseries where stars were born. And as more and more atoms were drawn into these clouds, the density increased, leading to the formation of galaxies. But let's pause for a moment to appreciate the scale of what we're talking about. A single galaxy can contain hundreds of billions of stars, and there are estimated to be over 100 billion galaxies in the observable universe. That's a lot of zeros. And yet, gravity was up to the task. It's like the world's best party planner, gathering all these atoms together, creating the perfect conditions for stars to form. And where you find stars, you find galaxies. But gravity didn't stop there. Within these galaxies, gravity continued to sculpt, molding clouds of gas into spinning disks, clusters, and other shapes we see when we gaze up at the night sky. It's a cosmic dance, choreographed by the force of gravity, playing out on an intergalactic stage. So, the next time you look up at the stars, remember the role of gravity in this grand cosmic spectacle. From the humble atom to the vast galaxies, gravity has been the silent architect, shaping the universe, one star at a time. Gravity, the silent architect, began to mold the universe into the cosmic spectacle we see today. Stars and planets like our Earth, how did they come to be? Our story now moves to a time about 1 billion years after the Big Bang, a time when the universe was a vast, swirling soup of hydrogen and helium atoms. These atoms, products of the first few minutes after the Big Bang, were now ready for the next step in their cosmic journey. Think of stars as cosmic kitchens. They take these hydrogen and helium atoms and, in their hot cores, cook them into heavier elements like carbon and oxygen. This process is known as nuclear fusion. Just as a cook combines simple ingredients to create complex dishes, stars combine simple atoms to create complex elements. But this cooking process isn't gentle. It's intense, fueled by unimaginable heat and pressure. Over time, stars, especially the large ones, can't contain this intensity. They explode in spectacular supernovae, blasting these freshly cooked elements into the vastness of space. But what happens to these elements, these cosmic breadcrumbs scattered across the universe? Here's where gravity, our cosmic chef, steps in again. It pulls these elements together, causing them to condense and form new stars, planets, and satellites. Consider our own Earth. The carbon in our bodies, the oxygen we breathe, the silicon in the rocks beneath our feet, all these elements were once cooked in the heart of a star, blasted into space, and then gathered together by the force of gravity to form our planet. This process, this cosmic cooking and gathering, happens all over the universe, giving birth to countless stars and planets. Each one unique, each one a testament to the incredible journey that began with the Big Bang. And so, in this vast cosmic kitchen, stars and planets were baked, each one a unique recipe of elements. It's a process that's been happening for billions of years, a process that continues even today. In this cosmic kitchen, stars and planets were baked, giving birth to solar systems like our own. From the Big Bang to the formation of planets, it's been quite a journey, hasn't it? Our cosmic odyssey, from the initial singularity to the universe we know today, is a compelling saga of transformation and evolution. Picture this. For a fleeting moment after the Big Bang, the universe was a hotbed of fundamental particles such as quarks and photons, with temperatures too extreme for anything else to exist. As the universe spread out, this energy diluted, causing a cooling effect, not too dissimilar to popping open a bottle of beer on a warm summer day. This rapid cooling was the catalyst for the creation of matter as we understand it. A mere 1/10,000th of a second post-Big Bang, protons and neutrons came into being. In a matter of minutes, these particles adhered together to form atomic nuclei, primarily hydrogen and helium. Hundreds of thousands of years later, electrons attached to these nuclei to form complete atoms. What happened next is truly breathtaking. 1 billion years after the Big Bang, these atoms, under the influence of gravity, gathered into colossal gas clouds, giving rise to clusters of stars known as galaxies. It's the same gravitational force that pulls a thrown ball back to Earth, or keeps our feet firmly planted on the ground. But where do planets like our Earth fit into this grand cosmic narrative? Over the course of billions of years, stars have been cooking hydrogen and helium atoms in their hot cores to create heavier elements such as carbon and oxygen. Large stars eventually explode, scattering these elements into the cosmos. This matter then condenses to form the stars, planets, and satellites that constitute solar systems like our own. And so, from a singular explosion, the universe as we know it was born, a testament to the remarkable story of cosmic evolution. The journey from the Big Bang to the formation of planets is a testament to the endless wonders and intricate complexities of our universe. It's a journey that continues to unfold, inviting us to explore, understand, and marvel at the cosmos that is our home.